In today's lesson, what we're going to be reviewing is the first part of statistics. So we're going to be focusing on the measures of central tendency and the measures of spread. So the first thing we want to look at is just some of the key terminology that we're going to be using or trying to find or calculate. So the mean is the average of the data. So basically that's telling us we have to find the sum or add up all of our data points and then divide by the number of numbers, or divide by how many values I have. The median value is the middle value of your data points, but the key thing is that it must be ordered from least to greatest. So we have to take our values and order them from least to greatest. The mode is the most occurring data point, so basically figure out what number occurs the most. The range is the difference between the greatest and least data value, or your highest and lowest data value. Quartiles are three values that divide a set of data into four equal intervals. A box and whisker plot is a graphical representation of those quartiles. So we can see here our box is represented by Q1, Q2, and Q3. And then our whiskers are the max and min values of our data set. The interquartile range is the range of the central half of data, or Q3 minus Q1. So basically it's telling us the range of values of our box. And then finally, standard deviation. Standard deviation is a value that tells you how spread out from the mean or from the average your data is. So how spread out is your data from what the average is. So in the first example, we're going to look at calculating some measures of central tendency. So we're going to look at finding the mean, median, and mode for the following sets of marks for two students. So the easiest one to start off with is the mode, because we just have to look and see which one occurs the most. If we look at Cindy, or we focus on her first, we see that no number occurs the most, so there is no mode. And you can have a couple options here when you're going through other examples. You could find that there is no mode, which means all numbers occur the same amount of times. You could have a single number, or you could have multiple numbers that occur the most. But if they all occur the same amount, you would say that there's no mode. To figure out the median, we have to put them in order from smallest to largest. So 60, 65, 70, 75, and 80. Here what we want to do now is find the middle value. And if there's an odd number of data points, in this case we have 1, 2, 3, 4, 5, there's only going to be one middle value. In this case, it's 70. If it was the case where we had an even number, we would have to take the average of our two numbers in the middle. And we'll look at an example later with that. So in this case, the middle number is 70. To find the mean, we have to add all of our numbers up. So 60 plus 65 plus 70 plus 75 plus 80, and divide them all by how many numbers we have. So in this case, 5. We should get 350 divided by 5, which is 70. So that means our mean is 70, or our average is 70. For Jody, we're going to do the exact same thing. We're going to start off looking for the mode, the easiest one to see. We can see that 80 occurs twice, so our mode is 80. To find the median, put them in order from smallest to largest. So 40, 60, 80, 80, and 90. Find the middle value. In this case, again, we're still looking at 5 values, so our middle number, there's only going to be one, which in this case is 80. And then for the mean, we add them all up and divide by how many numbers we have, which again is 5. We should get 350 again over 5, which equals 70. So the mean, or the average for Jody, is 70 as well. So this gives you an idea of how some of the values may be a little bit misleading. We look at Cindy and Jody, they both have an average of 70, but Jody's middle mark is higher than Cindy's, and she has more values at a higher mark than Cindy as well. So again, you can use these values to argue who you think is the better student. And as long as you use them correctly, there's no real wrong answer, depending on what you reference. So moving on to number 2. Number 2 asks us for the following set of data, determine the median, Q2, Q1, Q3, and the IQR, and then create a box and whisker plot. So again, it's important to note that the median is your Q2. So if you know how to find the median like we did in the last one, then that is how you find the Q2. What we want to do first then is put these all in order. So 5, 5, 7, 8, 8, 12, 13, 18, 23, 19 and then 23. So I've put them all in order. So in order to find the median, or Q2, I need to find the middle number. And if I count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means I'm going to have 2 middle numbers. When I go through and I count from one end, 1, 2, 3, 4, 5, that's halfway. 1, 2, 3, 4, 5, coming from the other direction, that's halfway as well. So I have 2 middle numbers in this case, which are 80 and 12, or 8 and 12. So to find the median with an even number, I have to add them up and divide by 2, and I get 10. So that means 10 is my Q2. Q1 is the median of the first half of your values. So I'm looking at these values right here, the first half, and I'm trying to find what the median is. In this case, there are 5 numbers, 1, 2, 3, 4, 5. So that means my Q1 is the middle number, which is 7. If there was a case where when we were finding the median, or Q2, it was an actual single value or data point that I have, then I couldn't include it in the Q1. But since in this case the Q2 of 10 is not an actual value or data point, I have to include the 8. Same thing for the second half, 12 to 23. I'm going to find the middle number. Again, there's 5 numbers in this half, so the middle number here is going to be 18, which is going to be my Q3. If I wanted to find my IQR, because that's the next thing it's asking for, that's your Q3 minus your Q1. So 18 minus 7 equals 9. Or no, not 9, sorry, 11. So your IQR is 11. To create your box and whisker plot, you need to have 3 lines first to create your box. So you have 7, which represents your Q1. You're going to have 10, which is your Q2. And you're going to have 18, which is your Q3. So if we connect those lines, that forms your box. Your whiskers then extend in both directions to your highest value, so in this case 23, which is your max, and to your lowest value, which is 5, or your minimum. If you want to label each line as well, Q2, Q3, and Q1. And there's a box and whisker plot that represents the spread of your data. What we want to do for number 3 is, using the set of marks in number 1, determine the range and standard deviation. So the range for Cindy, if we go back up and we look at our marks, we're doing the highest minus the lowest value. So in this case, it's 80 minus 60. Which equals 20. So that's the range. For Jody, I believe it was 90 is our highest mark, minus 40, which equals 50. Standard deviation is what we're going to figure out next, and we're going to use a table to help us with that. So you should be familiar with this table if you look back in the notes. The way it's set up, X represents the data values. So we had 60, 65, 70, 75, and 80. We already know that the mean for Cindy was 70. So what the x minus the mean is, or what that represents, is we do 60 minus 70, because x represents our data value. So that's 10. 65 minus 70 for the next one is 5. 70 minus 70, 0. Oops, sorry, these are negative values. 75 minus 70 equals 5, and 80 minus 70 equals 10. So that's the second column. The third column, x minus mean squared, is to take the answers we got, so negative 10, negative 5, 0, 5, and 10, and square these values. So I want to square the answers I got in my previous column. So we get 100, 25, 0, 25, and 100. One key thing, no negatives should be found in this last column. So once we square everything, we should make sure that all these values are positive, in which they are. The next step is to find the total, so we add all of these numbers up. So 100 plus 25 plus 0 plus 25 plus 100, we get 250. The next step after that, 250 divided by the number of numbers. So in this case, we have 5. So 250 divided by 5 is 50. In the last step, we take the square root of that. So the square root of 50 is 7.07. So that means the standard deviation for Cindy is 7.07. What I want you to do in the next one on your own is to do the same thing, but find the standard deviation for Jody's numbers. And then you're going to go through the exact same steps. The x is the data value, so the marks. Do the x minus the mean. Again, the mean for Jody was the same. It was 70. Then square your answer, add them all up, divide by how many numbers you have, and then square root that answer. And then from that, when you compare the two, so we know Cindy had a standard deviation of 7.07. Once you determine what Jody's standard deviation is, I want you to kind of try to figure out what conclusions can you draw from that data or from those values. So again, I recommend you pause the video and try this on your own. So coming back to Jody's data, if we fill out our table, we go through the steps to calculate the standard deviation, we should get a final value of 17.89. So we get that the standard deviation for Jody's data or marks is 17.89. So when we compare the two and we want to think about what conclusions can we determine based off of this, we can see that Cindy's standard deviation is 7 roughly, Jody's is roughly 18. Based off of that, we can say that Jody's marks are less consistent and more spread out. You can remember standard deviation represented how spread out from the average your data is. So we can say that Cindy's marks are fairly consistent, they're close to the average. Jody's are very spread out. And if we go back and look at each individual score, we can see that Jody's marks are more spread out than Cindy's based on what she has, whereas Cindy's, again, are more consistent, they're close to that average. So it's just a calculation or a measurement or a statistic that you can use to verify or to prove that the data is more or less spread out. And again, if you have any questions or you're a little bit unsure of some of these concepts, please go back to the actual lessons where we do focus on them in further depth.